So let's start with our electronics. Electronics. What do we study in electronics? Anyone? What do you mean by electronics?
The movement of electron.
Not the movement of electron. Electronics, not electrons. What else? Electronics is basically what? The branch of that science, right? That primarily uses what? The movement of electron, as you said, right? It is not the movement of electron, it is the branch of that physics. So electronics is basically branch of physics that primarily uses motion of electron or simply electron flow. Is everything is visible now?
Yes, sir.
Okay. Now let us study about the digital electronics. We are going to start with the digital electronics. What do you mean by digital electronics? What is a digital? If I say something, it is analog. If I say something, it is digital. What does it mean basically? Let's say the best example that we can give is of the watch.
Watch.
It is bigger. Three size, right? And something which is bigger than that. That is second, right? So this is a analog watch. This is what? This is a basically analog watch. We can also draw like this. 0425. This is a digital watch. This is very important to know the differences between them, right? It can be asked in the examination itself, right? Why I'm telling you these things? Because nowadays in 10 marker question, they sometimes ask you these types of questions. What are the differences between analog watch and digital watch? Similarly, in a crystal structure, we have seen that the difference between the TEM and SEM, right? So all these, the differences between two different technologies should be, you should know that. Also, it will be helpful in your science and tech part also. But again, from physics point of view, what are the common differences that you can see? Or what is the benefit of digital watch or analog watch over each other? What you can see from here? Here we can see that we have 4 places, right? And each places, the value can take place between what? This place can take value between 0 to 9. This place can also take value from 0 to 9. This place can also take value from 0 to 9. And this also can take value from 0 to 9 only. So we can put the digits in order of that, right? How many combinations are possible? How many combinations are possible?
9 to the power 4.
Yes. So total the combination which is possible here, that is not 9, it is 10 to the power 4.
10 to the power 4, yeah.
10 to the power 4, all combinations are possible, right? Nothing more than that, right? Can we say that the number is finite or not? Although 10 to the power 4 is a big number, but whatever the big, it is a finite number. Yes or no? Now, if we look on this watch, so it can give 10 to the power 4 combination of times basically, right? Nothing more than that. How many times, how many number of times you can watch from this clock? कौन कौन सा टाइम बता सकती है? जैसे ये 4:25 है, 4:27 हो सकता है. What are the possibility here? Can we say that it have infinite number of possibility? Yes or no? Yes, no.
तो ये वाला एक बार फिर से बता देना.
मैं क्या बोल रहा हूँ, जैसे यहाँ पर क्या है, फाइनाइट नंबर है, ओनली 0 to 9 टेक प्लेस हियर, राइट? यहाँ पर क्या है, सेकंड भी है हमारे पास, राइट? हमारे पास कितने हैं? इनफाइनाइट नंबर ऑफ पॉसिबिलिटीज है. यस और नो? जैसे लेट्स से कि ये 3 पर है और यहाँ है 12 और यहाँ कहीं है 1 और यहाँ कहीं है 2. लेट्स से ये पॉइंट कहाँ पॉइंट कर रहा है? कैन वी एग्जैक्टली से? और बहुत सारे नंबर हो सकते हैं, राइट? इफ यू कैन, यहाँ पे क्या क्या पॉसिबिलिटी है? यहाँ पे पॉसिबिलिटीज आर ओनली आवर्स एंड मिनट्स. यस और नो? यहाँ पे इसको देखे क्या क्या पॉसिबिलिटी कर सकते हैं हम लोग? आवर्स, मिनट्स, सेकेंड. सेकेंड के बाद क्या आता है? डिग्री. यस और नो? तो ये कंप्लीट ओवरऑल डिस्क्रिप्शन हो सकता है एक नंबर लाइन का. फॉर एग्जांपल, इफ वी हैव अ नंबर लाइन एंड 0 से 1 के बीच में कितने नंबर्स है? तो इनफाइनाइट नंबर ऑफ वैल्यूज. सेम विथ दिस एनालॉग वॉच. यस और नो? उसका सब डिवीजन तो बहुत छोटे छोटे हो सकता है ना, जितने तक हमारा लीस्ट काउंट है, जितने तक हम उसको ऑब्जर्व कर सकते हैं. यस और नो?
यस सर, इनफाइनाइट पॉसिबिलिटीज है. करेक्ट.
ज्यादा एक्यूरेसी कहां होगी? here it will be less accurate. Yes or no? अगर if the clock, if the minute hand is in between 1 and 2, क्या exactly बता सकते हो कि कहां पर exactly? नहीं. Yes or no? Compared to this digital clock, it is more accurate. Yes or no?
Yes sir, yes.
Now, is it continuous? A continuous set of value can be given here, but if you see here, it is discrete. Now, this is very important to understand these 4 possibilities. Also, one thing, noise is there, right? Do you know noise? Noise पता है सबको? पढ़कर आए हो 12th वाला? Noise is related to the accuracy, right? The more of the noise will be there, less accurate your measurement will be there, right? We will come to know that. Now, understand difference between continuous and discrete system. Which one is in reality? In reality, what happens? The discrete or the continuous? Okay, let me give you one more example. Let's say, have you used this radio, this type of radio? ढंग से समझो जो भी बताया जा रहा है, जो भी एग्जांपल्स है, बिकॉज दीज एग्जांपल्स विल हेल्प यू इन राइटिंग द कंक्लूजन. वहां पे तुम्हें दे देगा 110 को ऐड कर दो, या दे देगा एंड गेट और गेट, बट वहां पे कंक्लूजन क्या लिखोगे? दीज आइडिया, दीज रियल लाइफ एग्जांपल विल make you feel. Now understand, we have a radio one like here, right? And we have a knob here, and we have a cursor here, right? When you switch on the knob or rotate the knob, the channel will change, right? What are the possibility of channel you can get? Let's say at 93.5 we have red FM, right? So from here you can get 93.4 also. Here you can get 93.6 also, right? Have you ever observed that at 93.4 and 93.6 you will hear some noise along with the song? Yes or no? कभी देखा है ऐसा?
Yes, sir.
Right? Now, our number is this 93.5. Yes or no? Now, let us see our modern radio system. Here we have a radio system, right? And we will make blocks. Right? From the user end side, we will write here Radio Mirchi, Red FM, और क्या होता है? Any FM 3, huh? FM number 4, Suhana, Suffer with Anu Kapoor, जो भी है, whatever it may be, right? And at the back end, we will write 93.5 here. Here 98.3, right? These are the frequency ranges of these FM. So what does happen when you press this button? It will automatically play you the 93.5 FM. If you play this button, it will automatically provide you 98.3, right? So from, you can see here, from continuous to discrete system we are going, and it is always easier from the user perspective to use the discrete system, right? Understand, because it is very important when you're writing any question related to digital electronics, you need to explain these real life situations. Why digital electronics is so important? Because from the user end side, it is more user friendly, right? You can see even the user interface, even your mobile phone, the laptop, all the keywords are arranged in a discrete sense that each button will specify a different set of instructions. Sometimes it is logic also. For example, if you are using a MacBook, what is command plus C used for? Or if you are using a window, control plus C, what does it mean?
Copy.
Copy, right? Both command means basically copy, right? Here you can see that these two are different buttons. Command will do different things, C will do different things. C will paste C number on your screen, right? That is what you see on the user interface. But at the back end, if you press C only, it will tell the computer to see the C letter. But if you mix with command C, it will copy the text, right? This is how logic operations are performed, right? You're not going to write codes and that code will go to the computer and that will show you the result. You are only just expressing with the discrete keys that is in front of you. Is it clear to everyone? Right? For example, in nowadays, if you see the temperature regulator, right? We have thermometer. Have you seen? The old thermometer will look like something like this. Analog. And digital भी दिखता ऐसे ही है, right? But here is a measurement 23.5, something like this, right? It is digital. What is the difference between both of them? It can have multiple values. It can have only discrete values. Everyone got the idea? What is digital electronics?
Yes.
Which one is better, analog or digital?
Digital.
Why digital? Digital is user friendly, but it's not better always. What is the set of value that is present in the nature? They are analog always, right? तुमको अगर फीवर होगा तो 93.7, 93.72, 93.73, 97.34 सब कुछ पॉसिबिलिटी हो सकती है तुम्हारी बॉडी के टेम्परेचर की, राइट। बट तुम्हारा जो मेजरिंग डिवाइस है वो तुम्हें एक सेट ऑफ नंबर ही देगा, राइट। दिस इज बेसिकली द डिजिटल। नाउ कम टू द डिफरेंसेस बिटवीन एनालॉग एंड डिजिटल।
सर आवाज लैग कर रहा है।
बाकी लोग के लिए भी कर रहा है क्या?
हाँ, बीच में लैग कर रही है।
ये पता नहीं क्या इशू आ रहा है, देखते हैं जो भी है। क्योंकि मेरी तरफ से इंटरनेट कनेक्टिविटी भी सही है, ये जो इंटरफेस है वो जूम को यूज करता है, तो बाकी सब तो ठीक ही होना चाहिए, राइट। सो इफ वी टॉक अबाउट सिग्नल, व्हाट सिग्नल वी आर यूजिंग इन एनालॉग? Continuous signal, continuous sets of value, right? For example, tell me one thing. If we talk about the real number, right? Real number is a continuous signal, yes or no? And these are discrete, right? Now, what type of wave it will be? Let's say we are talking in terms of voltage, we are talking in terms of current, we are talking in terms of signal. What should be the shape of the wave? Sinusoidal wave? And here it will be what? Square wave. We have talked about these waves when we are reading the AC chapter, right? Let me show you the sinusoidal wave. This is a sinusoidal wave. Yes or no? And let's say, and this graph we are using, we are going to use more frequently here. This is a square wave, right? From here, it will having a certain value, then zero, then a certain value, then zero, right? It can be zero or something, right? That means it will have a certain kind of value. Is it clear, everyone? यहाँ तक clear सबको?
Yes, sir.
Okay. Next one. If we talk about the technology, right? If we need any technology here, what kind of technology we should know? Let's say if we have a machine here, right? Here also. It will give you output. Here also, it will give output, right? Here, we can simply send analog signal to the machine and it will give us output. Can we send analog signal here directly, or you have to use converter? Here we use converter. It then changes into digital signal, then into machine, right? Why it is so? Because any machine which is working on an analog signal, it just needs the analog signal. But if a machine is working on a digital signal, it need a converter, analog to digital converter. Even here also, it will not simply give you output. Here also converter is needed, right? Here converter will be analog to digital. Here it will be digital to analog, and then you will get the output. Why so? Because in real life, the input that we give and the output that we receive, the input that we give and the output that we receive are in the form of analog signal only, right? For example, if I am telling anything, right, my voices goes up and down. If you can check amplitude meter for the voice, for my voices, right? It will go up, down, up, down, up, down. It is something like analog, right? When you are speaking on the phone, even and you are sending any photos to anyone, right? All these things are in the analog format. यहाँ तक clear सबको?
सर रिपीट।
समझो इस चीज को, अगर हमारे पास कोई एक ऐसा मशीन है, ठीक है, इट इज इंपॉर्टेंट, बहुत इंपॉर्टेंट है, अगर हमारे पास कोई एक ऐसा मशीन है जो एनालॉग सिग्नल पर काम करता है, तो क्या करना होगा हमें? एनालॉग सिग्नल का इनपुट जाएगा मशीन के अंदर और हमें आउटपुट दे देगा, राइट? क्योंकि रियल लाइफ में जो भी इनपुट और आउटपुट है वो कैसा होता है? एनालॉग इन नेचर होता है, राइट? कॉन्टिन्यूअस होता है। जैसे मैंने बताया तुम्हें कि अगर टेम्परेचर की हम लोग बात करें या रेडियो एफएम की बात करें, फ्रीक्वेंसी की बात करें, तो कंटिन्यूअस एक रेंज है पूरा पूरा, राइट? ये सुनो, बट डिजिटल में हम क्या बात करें? डिस्क्रीट सिस्टम, नंबर्स आर फिक्स्ड, 10, 15, 20, 25, इवन लाख भी है तो वो फिक्स्ड है। तो जो हमें एनालॉग सिग्नल है उससे पहले कन्वर्ट करना होगा डिजिटल सिग्नल में, और फिर वो डिजिटल मशीन में जाएगा, और फिर वो कन्वर्ट होके हमें आउटपुट देगा। इज इट क्लियर?
यस।
Simply meaning, whatever the input or output we give into the machine are always analog in nature. If our machine is analog, then it will simply process the input and give us the output. If our machine is digital, it need a converter at both end, at the input also, at the output also, right? This is what. Now, next point. In which of the following the data transmission will be smooth? Right?
Hello.
Yes.
So why does it need a converter on the output end?
Because at the output end also we need an analog signal to process. हमारे पास जो भी चीजें आती है ना, that should be in analog in nature.
Okay, okay.
ठीक है?
तो इसका कोई एग्जांपल है, मतलब रियल लाइफ के?
और रियल लाइफ एग्जांपल,
जैसे आपने थर्मामीटर और रेडियो का ऐसे एग्जांपल देके बताया है, इसमें ऐसा कुछ है कि
से लेट से अभी हम लोग जो बात कर रहे हैं, हम लोग डिजिटल मशीन से बात कर रहे हैं, राइट?
हाँ जी।
इसके अंदर ट्रांसड्यूसर है, राइट? तुम्हारे इधर ट्रांसड्यूसर है, मेरे इधर रिसीवर है, राइट? ये दोनों कर क्या रहा है? ये वही कन्वर्ट कर रहा है। जैसे तुम जितनी भी चीजें बोल रहे हो, मैं जितनी भी चीजें बोल रहा हूँ, ये पूरा एनालॉग इन नेचर है। ये सुनो, कॉन्टिन्यूअस, पिच, हाई, बहुत कुछ है कि नहीं? एम्पलीट्यूड है, लाउडनेस है, पिच है, बहुत कैरेक्टरिस्टिक होती है साउंड की। ये सुनो, इन सारे को जो मेरे डिवाइस का जो ट्रांसड्यूसर है वो कन्वर्ट करेगा इसे डिजिटल में, और फिर जो तुम्हारे इधर का रिसीवर है वो अगेन उस डिजिटल को कन्वर्ट करेगा एनालॉग में, और फिर मैं जैसे बोल रहा हूँ सिमिलरली वैसे ही तुम्हें सुनाई दे रहा होगा उधर।
ओके ओके ओके, ठीक है।
ओके, नाउ इन विच ऑफ द फॉलोइंग डेटा ट्रांसमिशन विल बी स्मूथ? So data transfer is subject to deterioration, right? And you can say data transfer is without deterioration. मतलब थोड़ा बहुत तो समय होता है, बट again, which one is more accurate, less accurate? It is not that why it is the accurate less, because our input can be also less accurate, so our output will be also less accurate, right? एनालॉग में हमें मतलब ऐसा नहीं है कि कंप्यूटर की गलती है या फिर हमारे जो मशीन की गलती है, it can be human end also. It is more accurate as it is discrete in nature, right? Okay. हार्डवेयर किसमें कम यूज होता होगा?
डिजिटल।
एनालॉग में।
एनालॉग में फ्लेक्सिबल होता होगा? नो, hardware is not flexible. घड़ी देखो ना आपने, उसका हार्डवेयर है बस वो रोटेट करने के लिए उन चीजों को, राइट? दैट विल रोटेट ओनली, yes or no? In digital clock you can do a multiple stuff, yes or no, with the same hardware, yes or no? So hardware is flexible here. Why hardware is flexible here? Because most of the digital machine run on the software. Software is basically what? What is software, Himanshu? What is the software? तुम लोग IT वाईटी वाले हो यार, बताओ सॉफ्टवेयर क्या होता है?
तो कंप्यूटर प्रोग्राम्स होते हैं ना जो सॉफ्टवेयर होते हैं.
Yes. Softwares are basically computer programs, but basically they are algorithms, yes or no?
Algorithm, yes.
Algorithm is basically what? Logic, yes or no? If this is true, do this. If this is false, do this. Yes or no? So with these a limited set of hardware, we can do a multiple algorithm. We can do a multiple things. Yes or no? So hardware is flexible here. Even the number of hardware required in digital can be more when you are setting up the things, but it can do a lot more than work than in a analog system. Yes. Now, any example of analog? For example, our voice, right? Example, our voice, right? Here, example, computers, right? Digital watch. Can you tell me which one is more important in sending video and audio? Which one suits best when you are sending audio and video?
Digital.
No. Used in audio and video transmission. Right? And it is in any program or computation logic, right? Why? Basically, if you can, it is not like which one is cheaper, which one is easier, which one is more efficient in audio and video. So it will be analog because it will transfer all the input to the output that is required there, right? It can, when you're converting something, let's say if you're converting a PDF into a doc file, right? Some of the element may mismatch, yes or no? The same goes here also. When you're using a converter, some element may mismatch, right? It's just for your knowledge, nothing more than that, right? Which is easier to design? It is easier to design. You will see how. Okay. Noise free it will be, right? Noise immune, right? Easy fabrication in the integrated circuit, right? All these things are advantages of digital electronics. Easy fabrication समझ में आ रहा है क्या है? It can easily interact with the other components of that also. Done. Done.
Yes.
Okay. Now let's move to the other segment, that is basically the number system, right? See, from number system, from a very long time, they are not asking any question, right? But they can ask question. Let's say, for example, in waves and optics, we have seen that in 10 mark question, they have given 5 wave equations and ask which one of these HM or not, perform HM or not, right? Even in nuclear and particle physics, we have seen that in 10 mark question, small 2 mark questions are there, right? Similarly, in digital electronics, it might be possible that they can give you the basic number system problems, right? That you need to know how to add these, right? What is carry forward, what is in MSD, what is LSD, all those things is very important, right? So start with the first one is the number system. What is the number system? What is the number system? And why we need numbers? See, number systems are set of symbols that are used to denote a particular quantity of anything, right? Number systems are important to quantify anything. And based on the number system, we have 4 type of number system, right? First one is decimal. Second is binary. Third is octal. And fourth one is hexadecimal. Which is more important to us? This is more important to our syllabus. Decimal, binary, octal, or hexadecimal?
Binary.
Yes, binary is more important to us, right? Why? Because it uses only 0 and 1, right? Decimal ka example dena. 27, 43.25. Normal numbers that we use in daily life, right, are decimal representation only, right? And decimal representation are very good when you are writing any continuous range. It is very good, and we always use this number when you're using the continuous tense. Binary number uses 2 digit only, 0 and 1. Let's say 1010 0001. It is not 1. It is not 1010. It is 1010 or 001, right? It had different meaning. We will come to that also, right? Now, what is binary system is basically using digital computation. Basically, digital systems. In digital systems, we generally uses binary code. Why binary? Because what is the basic idea about logic? Anyone? अभी पूरा लॉजिक सीखना है हमें, लॉजिक गेट, लॉजिक कंप्यूटेशन, सब कुछ सीखना है हमें. What is basic in the logic? Logics have 2 operations basically, yes or no, right? Either it can be true or it is false, right? We will see how we can use these things. Now, what is octal system? Octal system, we will see, uses basically 8 power, and it is used in, again, digital system. It is again used in digital system, and it is more preferred or more advantage over binary system. Why it has more advantage over the binary system? Because it is easy to read, to record, to process, to write. Why? Because 3 sets of binary represent 1 set of octal number, right? That means if you're using 101 in binary, you need to use only 1 digit in octal system, right? Hexadecimal system are used in microcomputers. You will see, right? Nothing more than that is required for some decimal, binary, octal, and hexadecimal. We will talk more about binary, and we will talk about decimal to binary conversion and binary to decimal conversion. Some we will see about octal also, but let us first start with the decimal system. Understand, because decimal system you are using from your school days, right? Throughout our life, we have used only decimal system, right? So understand the concept in the decimal system, and the same thing will be applied in the binary operation or the binary system. So understand it very carefully. Why decimal? What does decimal means? It basically means that it has a base, right? It has a base or radix. It has a base or radix of how many numbers?
10.
10. ये पढ़कर आया क्या तुम लोग? That is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? What is the base or radix? What is the base or radix? It is basically, these terminology will be used in your question paper. The number of different digits which can occur in each position in the number. Base is basically the number of different digits. How many different type of digits we can use? 0, 1, 2, 3, 4, 6. So this is what we use in normal, our distinct system. Our normal distinct system is basically what? 10, right? 1, 0. If we say 1, 0, 5, 7, 4, 7, all of them are what? Same or different? Okay, next one. The decimal systems or even the binary system also we will see. It will have it is a position value system. It is a position value system. What is a position value system? Anyone? The value of the number depends upon the position. The value of the number depends upon the position. For example, let's say we have 5, 5, 5, and 5, right? All 5s are equal or different? It is at 1's place. It is at 10's place. It is at 100 place. It is at 1000, and it is at 10,000, right? We can also write it as 5 into 10 to the power 4 plus 5 into 10 power 3 plus 5 into 10 to power 2 plus 5 into 10 power 1. हुआ या और भी कुछ होगा? Plus 5 into 10 to power 0. It should end at 0 also, right? So all the, it is a position value system, right? ये भी क्वेश्चन आ सकता है, so that not about the decimal system, binary system पूछ देंगे, right? So that the binary system, right, or they can say the inputs that we use in the NAND gates are basically position value system. उस तरीके से घुमा के पूछा सकता है क्वेश्चन, right? So this is the basic thing that you should remember, that at each position, right, different 5 has different values and different meanings, right? ये जो लास्ट वाला है वो क्या है, 50,000 रिप्रेजेंट कर रहा है, उसके बाद 5,000, फिर 500, फिर 50, फिर 5. दैट इज वेरी इंपॉर्टेंट. ऑल्सो यहाँ देखो, हम लोग व्हेन वी आर मूविंग फ्रॉम लेफ्ट टू राइट, ये कौन सा डायरेक्शन है, लेफ्ट टू राइट टू लेफ्ट है, राइट टू लेफ्ट, राइट? डायरेक्शन कौन सी है? When we are moving from right to left, what we are doing, we are increasing the power of 10. We are increasing the power of 10. That means any number can be represented by its basis and position. And what is basically position? Position is basically 10 to the power x, right? 10 to the power x, and x depends upon where we are using this thing, right? Now, one more concept is very important here, the concept of MSD and LSD. MSD and LSD is very important. MSD full form, try karo. Most significant digit. And it is basically least significant digit. And try to understand with the example. For example, if you're writing 4, 5, 2, 1, 3, 5, which is more significant here?
Five.
5 is what? More significant, less significant?
Most significant.
Most significant is 5. Why?
रिपीट हो रहा है सर वो.
नहीं, रिपीट से क्या मतलब है? लो तुम उसको 6 कर लो, अब बताओ.
Sir, 4 is the most significant digit and 5 will be the least significant.
4 is more significant
Because the value of 4 will be accounts larger than the 5.
Yes, यही concept है. More significant digit, the highest value. Least significant, that will not make much sense. Clear? Done.
सर जो लेफ्ट पे होता है वो मोस्ट सिग्निफिकेंट रहता है क्या? फिर लेफ्ट वाला मोस्ट सिग्निफिकेंट, राइट मोस्ट इज लीस्ट सिग्निफिकेंट.
हाँ,
ओके.
राइट लेफ्ट बहुत मायने नहीं करता है, डिपेंड करता है उसकी वैल्यू, राइट? कौन सबसे ज्यादा जो है उस पूरे ग्रुप को रिप्रेजेंट कर रहा है, राइट? सो इट इज यहाँ पर जो है वो 4 है, बिकॉज 4 इज इंटू 10 टू पावर कितना आ रहा है यहाँ पर, 1 2 3 4 5 6 7, राइट? सो हायर द डिग्री ऑफ 10 टू द पावर x, हायर विल बी मोस्ट सिग्निफिकेंट इट विल बी. ठीक है, डन.
यस.
ओके, एक दो एग्जांपल करके दिखाओ तुम लोग. राइट इन द पावर ऑफ 10, write in the power of 10. Two, three, 4, 5, 6.254. What is ये इस point को क्या बोलते हो? What is this point is called? This point. नाम क्या है इसका? What is its name? अरे उस बिंदु को पॉइंट को क्या बोलते हो? जो यहां से हो गए वही सारे में है, इसलिए बोल रहा हूं मैं। क्या बोलते हो उसको? डेसिमल पॉइंट नहीं बोलते क्या इसको? क्या बोलते हो तुम लोग?
डेसिमल पॉइंट तो होता ही है। कुछ
वही
लगा
बोल,
कि कुछ अलग ही हो।
कुछ अलग नहीं, डेसिमल पॉइंट, राइट? We are using decimal system. This point is called decimal point. What is the significance of decimal point? Same binary point में same चीज हो जाएगा, क्योंकि what is the significance of decimal point? If we go here, the significance of the number will increase or decrease?
Increases.
Increases. Here it is MSD, yes or no? And if you go right here, the significance will
Decreases.
decrease, right? Also, to the left of the significant figure, we have to use 10 to the power positive value. To the left, we will use 10 to the power negative value. For example, if you write in terms of 10 to the power x, what you will write here? 1, 2, 3, 4, 5. 2 into 10 to the power what? क्या लिखेंगे?
4, sir.
Oh, sure. Yes. Plus 3 into 10 to the power 3. Plus 4 into 10 to the power 2. Plus 5 into 10 to the power 1. Plus 6 into 10 to the power 0. Plus here we have 2 to the power
-1.
-1. Plus 5 into 10 power -2. Plus 4 into 10 to power -2. Right? This is how we write this thing. Is it clear, everyone? Right? Now, if you can see here, 10, 10, 10, 10, 10, 10, 10, 10. What these 10, 10, 10, 10, 10 are indicating? That we are writing a number in a decimal system. Or this is the conversion, how we are doing conversion into a decimal system, right? Clear? Decimal system uses the power of 10. Clear? जल्दी बताओ, बाइनरी में पहुंचना है। Done ना?
Yes, sir.
Okay. Now come to the, let's say, binary.
देखो 10 की पावर -3 है ना 4 के साथ तो।
हाँ, ये -3 होगा।
ओके।
Binary system, same thing. First, can anyone, binary system uses what? Base of
0 and 1.
2. Base of 2.
Oh,
That is
sorry, 2. 2.
0 and 1. 0 and 1. Yes. अच्छा, एक चीज बताओ, number of digit, can we say that number of digit is proportional to 1 by base? Yes or no? जितना ज्यादा हमारे पास नंबर होगा उतना कम डिजिट यूज करना पड़ेगा फॉर मेकिंग ए नंबर। यस और नो? अच्छा, इस पे आते हैं हम लोग। ठीक है, ठीक है, इस कॉन्सेप्ट सीखते रहिए। यहाँ तक ठीक है? It has a base of 2, 0 and 1. Does it has a position value system? Yes. It also has a position value system. It also has a position value system. That means the value of the number depends upon the position where it is kept on, right? Now, what are the advantages of using binary system? What are the advantages of binary system? ये बता दो, important है. Any advantage? It has a lesser base. Yes or no? Base less है या नहीं है?
बट सर वो एडवांटेज कैसे है, मतलब लेस बेस तो है.
अच्छा हाँ, ये बात भी है. अगर लेस बेस है तो कैसे एडवांटेज है? लेस बेस इज एडवांटेज, राइट? लेस बेस के कारण लंबा कीवर्ड लिखना पड़ता है, दैट इज डिसएडवांटेज. ओके, लेस बेस दैट मींस द नंबर of the input are less. Yes or no?
यस.
ठीक है. अब see, the problem here is not the base size. If we can do the same computation with the only two input, right? Which one is better? 2 inputs or 10 inputs? If we can perform the same process.
The one with the less input is better, binary.
Right? Now understand one thing. Let's see. 1 0 0 1 0 0. It is basically 2 into 2 plus 0 into, sorry, 2 to the power 2 plus 0 into 2 to the power 1 plus 0 into 2 to the power 0, right? Now if you want to build a computer will see that it has to multiply 2 to the base something, same and the decimal system. You will program that 10 to the power x you have to use. Here you will program a computer that 2 to the power x you have to use. यहाँ तक clear है? Same thing, yes or no? One computer will process with 10 to the power x, one computer will process 2 to the power x. Both are same, yes or no? यहाँ तक तो सेम है. Yes, no. एक नंबर है, उसके बाद x कंप्यूट करना है हमें. बट हियर यू कैन से ओनली 2 डिजिट्स आर पॉसिबल. तो कंप्यूटर को आइडेंटिफाई कितना करना पड़ेगा? या तो 0 या फिर 1. अगर यहाँ कंप्यूटर को आइडेंटिफाई करना होगा, इट हैज टू आइडेंटिफाई 9 डिजिट्स with the combination of 10 to the power x. Here the computation has to do only with 2 numbers into 2 to the power x. Yes or no?
Yes sir.
ये समझ आ रहा मैं क्या बोल रहा हूं? हमने एक मशीन बनाई जो 2 to the power x करके कोई नंबर लिख सकती है. हमने एक मशीन बनाई 10 to the power x करके कोई नंबर लिख सकती है, राइट? हम लोग यहाँ इनपुट देंगे, यहाँ पे आउटपुट निकलेगा. यहाँ इनपुट देंगे, इधर आउटपुट निकलेगा. आउटपुट मान लो कि 10 नंबर, आउटपुट इज 35 मान लो. दोनों मशीन जो है वो 35 नंबर प्रिंट कर सकता है स्क्रीन पर, राइट? एक ऐसा है और एक ऐसा है. इस वाले में हम सिर्फ 0 या फिर 1 डाल सकते हैं. इस वाले में हम 0 1 2 3 से लेकर 9 तक कुछ भी डाल सकते हैं. Which one will be more efficient, more convenient, easy, and the competition process will be easier? किसका होगा?
2 to the power x.
अब समझ में आया why we use binary over the decimal?
Yes sir.
नंबर लिखना पड़ रहा है, but they are strings, right? So advantage is basically what we will write? Faster computation. और क्या लिख सकते हैं? सिंपल कंप्यूटेशन. right? And also follows Boolean algebra. And Boolean algebra is a breakthrough when we are talking about logic gates and logic circuits, right? We will come to this. What is Boolean algebra? Okay, now everything is clear. अब कैसे हम लोग लिखते हैं, क्या नंबर है वो देखते हैं हम लोग. राइट, एक नोटेशन भी तुम लोग देख लो. नोटेशन इज बेसिकली, लेट्स से 101, इट इज 101 और 101, पता नहीं चल रहा ना. तो इफ इट इज इन डेसिमल सिस्टम वी विल राइट 10. तो क्या बोलते हैं, सबस्क्रिप्ट, सुपरस्क्रिप्ट, सबस्क्रिप्ट बोलते हैं, सब बोलते हैं, नीचे वाले को सब, ऊपर ऊपर. सो इट इज in decimal system and we will see it 101 if it has a base 2, that means it is in a binary system. The basic notation is there, right? Now let's use here, we are saying the position value. One example of position, let's say we have 1 0 0, binary system में लिखा जा रहा है. We can write 2 also here, right? What is the number in the decimal system? What is the number in the decimal system?
In decimal or in binary?
Decimal. It is written in the binary system. 1 0 0, it is written in the binary system.
4.
How will write the value? 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 0 into 2 to the power 0. It is 4 plus 0 plus 0, that is 4, right? Now see the same thing. Decimal point, when you are going this side, 10 the power increasing. When you are going this side, the power of 10 is decreasing, right? So we can simply say that here, let's say if this is the, what is the name of this point? Binary point. It is the binary point. Let's say 1 0 0 0 1 0. If this is a number in binary system, this is what? Binary point. When you are going this, 2 की वैल्यू क्या होगी? Increase or decrease? Value of 2 will decrease to the power minus 1, to the power minus 2, to the power minus 3, and so on. When you go this side, the power of 2 will increase to the power 1 0, to the power 1, to the power 2, and so on. Are you getting the thing? Yes or no? Same, this question and this question is basically same. Just try to write this. ये समझ आया क्या हुआ है? ये क्वेश्चन और करेंगे इसमें. ये समझ आया क्या हो रहा है, right?
Yes, sir.
Find out the value in the decimal system, right? Value निकालो क्या है इसका. So binary to decimal. No need to write these steps. अगर समझ गए हो तो, नहीं तो step by step लिखवा दूंगा मैं. So binary, question number 1 1 0 0. Question number B 0 1 0. All of them are in binary. 2 2, it's subscript. 1 1 0 1 2. D any time it can be asked in the examination, any time. Giving you 5 minutes. Do it fast. देखो इलेक्ट्रॉनिक्स में हमें ये जो छोटे छोटे टॉपिक्स है ना, इसे बहुत ही अच्छे से करना है। ये अगर आए तो इसे छोड़ना नहीं है। One more thing, when you're solving these things, do you know what is bit? These 0, 1 are called bit. Yes or no? How many bits are there in 1 byte?
16.
Huh? 1 byte contains how many bits?
16.
8. 1 byte contains 8 bits. Okay. How many megabyte are required to make 1 gigabyte?
1032.
1024. Done. Done. Done.
Yes, sir.
Okay, starting with the first one. So first one, 1 into 2 to the power. How will you count? 0, 1 and 2. Plus 0 into, sorry, it is plus 1 plus 0 into 2 to the power 0. 4 आया ना? 4,
Yes, yes, sir.
0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 0 into 2 to the power 0. कितना रहा ये? 2, right? Now understand, this notation represents 2 in decimal system. 1 0 you can write, or it is clear here, we are converting from binary to decimal. Okay, here 1 into 2 to the power 1 plus 1 into 2 to the power जल्दी बताओ 0 plus 0 into 2 to the power minus 1 plus 1 into 2 to the power minus 2 कितना है देखो ये it is 2 right it is 1 it is 0 it is 1 by 4 that is 0.25 raise your hand ये अगर सही आया तो 3.25 वाला ठीक है next come to this one right? So 0 1 2 and 3 so 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0 plus 0 into 2 to the power minus 1 plus 1 into 2 to the power minus 2 plus 1 into 2 to the power minus 3 क्या आ रहा है देखो it is 8 plus 4 plus 0 plus 1 plus 0 plus 1 by 4 plus 1 by 8 ये आ रहा है ना
Yes, sir.
ठीक है similarly here also दो कितना आएगा 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0 plus 1 into 2 to the power minus 1 plus 0 into 2 to the power minus 2 plus 1 into 2 to the power minus 3 कितना है जल्दी बताओ दोनों का आंसर फर्स्ट
5.625
ठीक है गुड okay so this is simply the basic method right this method is basically the simplest method right? one more method are used सीखना है या छोड़ दे ठीक है one more method are used that is called double that method right double that method it is for using converting binary to decimal right now how it goes on ये सीखना होगा तुम्हें ये एग्जांपल से ही समझाता हूं मैं example let's say you have to convert 1 1 1 1 0 0 1 1 1 0 0 1 now what you need to do you can write it also whatever mode you prefer just double the first one right double it what become 2 right then add the next one plus 1 it will become 3 then again double it then add the next term then again double it then add the next one then again double it and add the next one right try to do so it basically double it then add next then repeat till last digit बताओ क्या आएगा double it 2 then add 1, it will become 3. Then double it will become 6. Then add 0, it will become 6. Then again double it will become 12. Then add 0, it will become 24. Then again add 1, 25. One more time. Double it, 2. Good. Then add 1, it will become 3. Add 1, it will become 3 here. ऐसे कर लेते हैं, 3. Then double it becomes 6. Then add 0, it will become again 6. Then double it will become 12. Then again add 0, it will become 12. Then again double it will become 24. Then add this will become 25. समझ आया थोड़ा थोड़ा?
Yes, sir.
ठीक है, so this is called double add method. ट्राई करो ये 100 वाला, 100 10110. ट्राई. सर ट्राई कर लेते हम लोग. Double it 2, then we will add 0, it will become again 2. Then we'll double it, it will become 4. Then we will add 0, then again we'll double it, it will become 8. No. So 100 what 8 4 ही रहेगा क्या? हाँ 4 ही रहेगा. 4. Because this is the last addition. समझ आ रहा है ये? Double 8 plus 1 till your last digit. So here we have, यहाँ हमने डबल किया 2 हुआ, फिर 0 जोड़ा, 2 हुआ, फिर डबल किया 4 किया, फिर लास्ट वाला क्या है 0 ही, तो 4 4. सेम हेयर देखो इधर, double it 2, then add 0 become 2, again double it become 4, then add 1 become 5, then double it become 10, then add 1 11, then double it become 22, then add 0 again become 22. Right? Try to do using the previous technique also. Previous technique में क्या करना था हमें? Multiply with 2 0 to power 1 to power 2 to power 3 and to power 4. Try करो क्या आ रहा है? 2 power 4 is 16. कुछ गड़बड़ गया देखो तो. हाँ 16 plus 0 plus 4, right, plus 2 मतलब 16. Next one is 0, ये तो 0 हो जाएगा, ये again it become 4. This will give you 2, then again 0. Yes, 22. Clear? ये मेथड समझ आया?
सर पार्टिकुलर मेथड भी मेंशन कर देता है क्वेश्चन.
देखो अगर तुम मानो क्या बात करें, अगर 2015 के बाद देखें तो नहीं, बट एक अगर क्वेश्चन में बताऊं तो मैं बस 1 मिनट रुक जाओ, बता रहा हूँ मैं. जैसे ये हम लोग पढ़ रहे हैं तो लिखा हुआ है, एक क्वेश्चन आया है, सिंप्लीफाई द लॉजिकल एक्सप्रेशन यूजिंग कार्नोव मैप. ठीक है, 10 नंबर का 2010 में. तो जो फेमस मेथड है वो नाम जानना सही रहता है. ठीक है, ओके. देखो समझो, जो मैं बता रहा हूँ इलेक्ट्रॉनिक्स में, द बेस इज क्वाइट बिग देन बेसिकली इट इज डिपेक्टेड इन द मार्केट, जो मार्केट में है उससे लगेगा कि ज्यादा पढ़ रहे हैं, बट वी आर स्टिकिंग टू आवर सिलेबस, जो सिलेबस में लिखा है उस हर एक चीज को पढ़ रहे हैं, और खासकर जो इजी चीज है उसको बिल्कुल भी नहीं छोड़ रहे हैं। इज इट क्लियर? फॉर एग्जाम्पल, अगर कन्वर्जन बाइनरी टू डेसिमल आता है, जो कि एक बार आया हुआ है कि लॉजिक जो है बुलियन लॉजिक को जो है वो कार्नोग मैप से करे सॉल्व। अगेन कार्नोग मैप इज नॉट अवेलेबल इन एवरी बुक, राइट? डिजिटल इलेक्ट्रॉनिक्स जो आती है किताब उसी में बस लिखा होता है। सो जो छोटे छोटे टर्म्स है, जो इंपॉर्टेंट मेथड्स है, दैट वी नीड टू नो। क्लियर है?
सर तो ये कन्वर्जन के लिए जो आता है इसमें तो डायरेक्ट आंसर मेंशन कर दिए, जैसे 100 का है तो उसको 4 आंसर मेंशन कर दिए, तो उसके अलावा भी कुछ लिखना होता है कि बस हो गया?
इसी को लिखो ना अच्छे से, इसी को लिखो। The digit in the first rightmost place is 1, we will multiply it by 2, it will become 2, right? ऐसे लिखोगे इसको अगर तुम।
अच्छा, मेथड एक्सप्लेन करना होता है
हाँ,
कि कैसे
व्हाट यू
किया?
राइट, यू राइट डबल डेड मेथड क्या होता है, राइट? मल्टीप्लाई बाय 2, देन उसके बाद तुम इसको से लिखोगे यूजिंग डबल डेड मेथड वी आर गोइंग टू कन्वर्ट 101 इन द डेसिमल सिस्टम। फॉर दिस व्हाट वी नीड टू डू, वी नीड टू multiply each digit with the 2 and add to the successor digit. So that means we need to 1 into 2 is equals to 2. Then we will add 1, that makes 3, right? Then the next number will be 3 into 2, that will make 6, so on. इस तरीके से चलेगा काम। क्लियर?
यस।
डन, यहाँ तक हो गया ना? फटाफट करो। नेक्स्ट, डेसिमल टू बाइनरी। सिर्फ बाइनरी सीखेंगे हम लोग, हेक्साडेसिमल और सेम होता है वैसे ही। डेसिमल टू बाइनरी हाउ विल वी डू? तो इसको हम लोग दो सेक्शन में देख लेते हैं। फर्स्ट वन इज हाउ विल डू विद द इंटीजर्स। दैट मींस व्हाट आर इंटीजर्स? दैट आर बेसिकली at the left hand side of the binary point. If this is the point, here we have integers and here we have fractions, right? So what we will do with integers, right? So again we have double dabble method. कौन सा मेथड यूज करते हैं हम लोग यहाँ पर? डबल डैबल मेथड। यहाँ पर क्या था? डबल डैड मेथड। डैड मतलब एड, डैबल मींस दैट मींस वी आर कन्वर्टिंग फ्रॉम डेसिमल टू बाइनरी, राइट? क्या करते हैं इसमें? लिख लो। In this method, it is also known as divide by 2 method. It is also known as divide by 2 method, right? Write down, in this method, we progressively divide the given number by 2 and write down the remainders after each division. ठीक है? Remainders are then written in reverse order to obtain the number in binary form. Done.
Yes, sir.
ठीक है. This is for integer. Always remember, this is for integer, not for fraction. So let's say, let's take one example. If we have 25 and 25, it is in the decimal system, we need to write in the binary system. What it will do? 25 by 2, or you can use the divide symbol. क्या देगा ये? 12 plus 1. Yes. Then we have 12. If we progressively divide, what will remainder? 12. Then we will divide by 2. It will gives us 6 plus 0 remainder. Then again 6 को divide करेंगे. 6 divided by 2. It will give us 3 plus 0. Again 3 is divided by 2. What will be remainder? 1 plus 1. Right? Then 1 will be divided by 2. What will be the remainder? Right? Now again, if you divide anything with the 0, it will always give you 0, 0, 0, 0. Right? So we will end here. Right? Now, we got the number. These are the remainders. These are the remainders. Write them in the reverse order. That means reverse means 1, 1, 0, 0, 1. 1, 1, 0, 0, 1. That is, it is in binary, represent 25 in the decimal system. Is it clear, everyone? Clear or not? Jaldi batao.
Yes, sir.
Again, try to do one more. Let's say 80. We'll try 80. 80 divided by 2 will give us 40 plus 0. 40 divided by 2 will give us 20 plus 0. 20 divided by 2 will give us 10 plus 0. Check करना गलती ना हो जाए. 10 divided by 2 will give us 5 plus 0. 5 divided by 2 will give us 2 plus 1. 2 divided by 2 will give us 1 plus 0. 1 divided by 2 will give us 0 plus 1. Right? Write these in the reverse order. You will get the डन. देख लो कुछ गड़बड़ तो नहीं हुआ आपने से.
Yes, sir. Done.
Okay. Now come to the fraction. For the fraction. Same method. Same method we are using. Name of the method is same. Here we will multiply the two. Right? So multiply by 2, then record the carry in the integer. integer position, right? Then take the forward direction. Here we are using the reverse, here we are using the forward direction to get the number in binary form. Example. Zero 0.8125. This is given, right? How will do? कैसे करेंगे बताओ? Multiply by 2, then record the carry, right? So 0.125, we will write here 0.125 into 2 is equals to 1.625. 1.625. Here we will write the carry. What is the carry here? Carry समझ में आता है ना? 5 to the 10, 0 remaining, 1 is the carry. Yes or no? What is the carry here? 1. Here, 1 in the integer position is the carry. You need to write the integral position basically, right? Then again, 1.625 into 2. It will give you, sorry. Let me write like 1.0.625. Then we need this digit. 0.625 into 2. It will become 1.25. That can be written as 1 plus 0.25, right? This is the fraction part that we need to convert. 0.25 into 2. And this is the integer part, that is 1. Again, 0.25 means 0.5. 0.5 can be written as 0 plus 0.5. That means the carry of 0 only, right? Again, this integer should be multiplied 0.5 into 2. It will become 1. And 1 can be written as 1 plus 0.0. That is carry is 1. Now, here we will stop. When we get the 0.0, we will stop. The required number is 1101. Got it? समझ आया ये चीज? Yes, no, जल्दी बताओ.
Yes, sir.
ठीक है, फटाफट एक लास्ट क्वेश्चन करो इस पे. क्या दिया अपना हो गया खत्म. Convert 25.625 into binary equivalent. अच्छा एक चीज बताओ फटाफट तुम लोग, हमने ये देखा है, राइट? इन डेसिमल वी हैव 10 to the power x system. Here we have 2 to the power x system. Here we will have 8 to the power x system. Here we will having 16 to the power x system. समझ में आ रहा है? कर लोगे ऑक्टल हेक्साडेसिमल, ऑल्दो ये नहीं पूछेंगे ऑक्टल हेक्साडेसिमल कभी भी. The maximum they can go between binary and decimal only. समझ आ रहा है मैं क्या बोल रहा हूँ? अगर हमें डेसिमल बाइनरी आता है कि हम ऑक्टल और हेक्साडेसिमल सेम लॉजिक पे लगा सकते हैं. if we know 10 to the power x to the power x कैसे use करना है, कैसे convert करना है, can we do the same thing in 8 to the power x and 6 to the power x? Yes or no? जल्दी बताओ. दिक्कत हुई क्या?
ऑक्टल में 0 to 7 और हेक्साडेसिमल में 0 to 15.
नहीं होता है, वो लिख देता हूँ. चलो एक चीज और लिख देता हूँ मैं. जैसे इसमें था हमारा क्या था, 0 1 2 3 4 5 6 7 8 9. इसमें था 0 और 1, और इसमें है हमारा 0 1 2 3 4 5 6. ठीक है, 6 ही तक है, सॉरी 7 तक. इसमें कितना होगा? 50 नहीं जाता, फिर हम लोग लेटर पे आ जाते हैं. 0 1 2 3 4 5 6 7 8 9. A B C D E. दो तो E तक जाएगा, F तक जाएगा. 16 गिन लो, काउंट 16.
ई तक जाएगा.
F तक जाएगा. 10 और 6, राइट. Yes, no. डेसिमल पॉइंट, बाइनरी पॉइंट, ऑक्टल पॉइंट, हेक्साडेसिमल पॉइंट, राइट. पॉइंट से अगर हम लेफ्ट जाएंगे इंक्रीजिंग नंबर ऑफ एक्स, पॉइंट से अगर लेफ्ट जाएंगे राइट जाएंगे तो नेगेटिव पावर ऑफ एक्स. यस और नो? रेयर ऑफ द रेयरेस्ट चांस की पूछेंगे वो, ठीक है. बाइनरी पूछ ले, यही बहुत है. डन डन. ये क्वेश्चन हुआ. Here we have two part. We have integral part 25. So this can be written as 25 plus 0.625. 25 plus 0.625. Right? Or not plus, simple. 25 और 0.625. इसके लिए क्या करना था? डिवाइड वाला 25 divided by 2, 24 plus 1. Again we will divide this. 24 divided by 2 becomes 12 plus 0. Again we will divide 12 2, it will become 6 plus 0. Again divide 6 by 2, it will become 3 plus 0.
सर गलत होगी.
हाँ, यहाँ 12 होगा. So 12 here will be 6 6 3 3 1 1, right. 1 divided by 2 it will become 0. Now 0 divided by 2 every time it becomes 0. So here we will stop. यहाँ रुकना होगा हमें, right. Here which order we will use, forward or reverse? Order will be
रिवर्स.
reverse order, right. So here the number will be 1 1 0 0 1 1 1 0 0 1. So 25 can be written as 1 1 0 0 1. Now let us see 0.625. So 0.625 will be multiplied by 2, right. So it will become 1.25 and we have to take the carry. What will be carry? So 1 plus 0.25, carry will be 1. Again 0.25 will be multiplied by 2, it will become 0.5, and 0.5, what is the carry here? It is 0.5, carry is 0. 0.5 is again multiplied by 2, it will become 1.0. Here 1.0.0, carry is 1. Yes or no? यही है ना?
Yes, sir.
Reverse order? No, it will be in forward order. Yes. So if you use this order, it will become what 101, so कर दो add, so 25.625 in decimal system is equal to 11001. Now decimal 101, not decimal, it is binary point. समझ रहे हो ना? This point is what? Decimal, जो normally बोलते हैं decimal point को. But this is our binary point, right? MSD, LSD, you can write. Done up to, हो गया यहाँ तक?
Yes, sir.
Okay. Now tell me, what does shifting in place will affect? Shifting in place will affect. Let's say shifting the place point. Place point means decimal point, binary point. Now, if we shift the decimal point, let's say if we have 25.24, right? And let's say we have 25.2.4 and we have 2.524. What does it mean? When we have shift the decimal, when we have shifted the decimal to the right, what we have done? When we have shifted right or left?
Left, sir.
Left. When we have shifted left, then what we have done? Divided by 10. Yes or no? ये तो किया हमने. When we have shifted to the right, what we have done? We have multiplied by 10, right? That means in the decimal point or the decimal system, if you are shifting the base point, that is the point that you are seeing there. If you are shifting the point, that means you have multiplied with the 10, right? If you are shifting the left, wait a minute. ये समझ में आ रहा है सबको?
Yes, sir.
Now, if we have 1010, right, point here, and if we have a point something like 101.0, and if we have 1.010, here what we have done? Shifted to right, and here we have done shifted to left. What we have done actually? What is the change in the number? The number here is here 25.24 become 2.524, and here it become 252.4. Will there be any changes here, or it will remain same? Is there any changes here, or it will remain same? नंबर वही है, चेंज हो गया?
चेंज हो गया सर.
चेंज हो गया. व्हाट इज द नंबर? ये नंबर क्या है? देखो डेसिमल में कन्वर्ट करने की कोशिश करो. देखो क्या नंबर था ये नंबर क्या था? देखो तो ये था 2 to power 0 0 to power 1, that is 2.5 2.5 था ना?
2.5.
ठीक है. एंड दिस नंबर बिकम, ये क्या हो गया? ये लैग कर रहा है क्या धीरे धीरे? ये नंबर कितना है 1.0.1
शिफ्टेड टू राइट वाला 5 हो गया.
ये 5 हो गया. ठीक है, और ये क्या हो गया? ये देखो क्या हो गया. क्या ये 1.25 हो गया?
1.25, yes.
राइट. सेम लॉजिक, बेस 10 और बेस 2 का क्या फर्क है? इट इज मल्टीप्लाइड बाई 2 एंड इट इज डिवाइडेड बाई 2. याद रखना ये सब सारी चीजें, ये सारी चीजें इतनी बेसिक है और इतना इंस्टेंट चाहिए कैलकुलेशन में. यू कैन नॉट फॉरगेट दीज स्मॉल स्मॉल पॉइंट्स. ओके, नेक्स्ट पॉइंट is the binary operations, right? That we also will using in the logic gates. These operations are always also helpful when we do Boolean algebra. All these are in the syllabus, and all these things rely on this part only. पूरा का पूरा Boolean algebra इस पे है, truth table इस पे है, logic gate इसी पर है, right? Binary operation को बहुत ढंग से समझना, it is very important. So what type of binary operation can possible? कितने possible है? Addition, subtraction, multiplication, and division. Multiplication and division, right? One next most important feature of binary operations or binary is that it makes the computation more simpler. That means if we can see here, it is very important. What is subtraction? It is the addition of complement. We will see what is complement, a and a bar. We will see. Yes or no? In decimal system, 2 minus 3, let's say. When we talk about decimal system, example लेते हैं, right? Addition का example 5 plus 2 7, quite fine. Subtraction, let's say 5 minus 2 is basically 5 plus of minus 2. Yes or no? जल्दी बताओ. Yes, so it is the addition of its complement. So what is the complement of 2? It is minus 2, right? Again, let's talk about third, 2 into 5. It is the multiplication. Again, we can see that 2 plus 2 plus 2 plus 2 plus 2, right? So the multiplication is again repetitive addition. See, we have full adder, half adder circuit, right? That we will see in the next class, most probably, right? In all of them, this is the logic or this is the thought process while we are making any circuit. जब भी हम कोई circuit या logic gates बना रहे होंगे या combine कर रहे होंगे, that should be in our mind that subtraction is what? It is addition of always complement. What is multiplication? It is repetitive addition. What is division? Let's say 10 divided by 2. What is division? Anyone? डिवीजन क्या होता है? Division is basically repetitive subtraction. Division basically repetitive subtraction, right? So what we will do, we are dividing 10 into 2 parts, right? So how can we write 10 into 2 parts? That means 5 plus 5 and we have to make two parts. 5 is the answer here, right? So division is also a repetitive subtraction. ये समझ आ रहा है मैं क्या बोल रहा हूँ? अभी हम लोग करेंगे why it is called universal gate, why it is universally accepted, right? Why only adder circuit will make all the operations. समझ आ रहा है ये चीज?
तो ये तो डेसिमल सिस्टम के लिए है ना, बाइनरी ऑपरेशंस के लिए
सब कुछ सेम है ना? बाइनरी डेसिमल में अंतर क्या है? बस डिजिट ही तो अलग अलग यूज कर रहे हैं, 0 to 9 यूज कर रहे हैं, 0 1 यूज कर रहे हैं, बाकी ऑपरेशन तो सेम ही होगा ना। यहाँ से मैं तुमसे समझा रहा हूँ कि एक्चुअली में एडिशन सब्ट्रैक्शन मल्टीप्लिकेशन सब कुछ एक ही चीज है। जैसे 10/2 को देखो अच्छे से, राइट? सो इट इज व्हाट 1/2 multiplied by 10, that is 1/2 plus 1/2 plus 1/2 plus up to 10 times, यही है ना?
ठीक है
तो 5 ही देगा, yes or no? So whether it is subtraction, multiplication and division, it can be done through addition process, yes or no?
यस सर।
ठीक है, जैसे फॉर एग्जांपल अभी हाफ एडर का क्वेश्चन है हमारे पास, राइट? ठीक है, व्हाट इज द प्रिंसिपल यूज इन हाफ एडर, गिव द ट्रुथ टेबल ऑफ इट। 2014 में क्वेश्चन पूछा गया है, राइट? हम लोग देखेंगे हाफ एडर होता क्या है, बट तुम्हें ये समझ में आना चाहिए ना कि जो ट्रुथ टेबल बनाएंगे और बाकी चीजें, अगर हम सिर्फ एडिशन वाला यूज कर रहे हैं तो क्यों ये एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन और डिवीजन सबको रिप्रेजेंट कर रहा है? इज इट क्लियर? जल्दी 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 बताओ।
यस सर।
ओके, नाउ लेट्स सी द एडिशन। Addition of binary, there are only 4 rules, right? Basically, और 5 रूल कह लो, नहीं 4 में हो जाएगा, चलो 4 रूल्स ऑफ एडिशन, दैट इज वेरी इंपॉर्टेंट। ध्यान सुनना, इट इज मोस्ट इंपॉर्टेंट। फर्स्ट वन, अगर किसका लॉजिक नहीं समझ में आए तो पूछना जरूर। फर्स्ट, 0 plus 0 is 0. 2, 0 plus 1 is
1.
1. 1 plus 0 is 1.
1.
1 plus 1 is
1.
it is 10. 1 plus 1 is 10 in binary operation. It is not 10, it is 1 0. And also it is a bad way of saying 10. इसको लिखते हैं हम लोग 1 plus 1 is 0 with a carry of 1. With a carry of, समझ में आता ना? जैसे हम लोग 9 plus 1 क्या लिखते हैं? 10, that is 0 and a carry of 1. Yes or no? 2 3 9 4 6, कैसे ऐड करते हैं हम लोग उसको? 9 plus 6 15 with a carry 1. 15 हुआ ना, तो 5 लिखा हमने, 5 is here and 1 is what? Carry. 4 3 7 1 8 and 285. Is it clear? Meaning of carry? जल्दी बताओ. Is it clear? What does it mean? 1 plus 1 is 0 with a carry of 1. ठीक है, ये क्लियर है? ये डेसिमल बता रहा हूं तुम्हें, 2 3 9 और 4 6 वाला। Done. Fast.
तो 1+1 तो 1 होना मतलब पढ़ा था ऐसा लग रहा है।
नहीं, in addition subtraction is 1 plus 1 is 0 with a carry of 1 to the next most significant bit. तुम क्या सोच रहे हो बता रहा हूं मैं। लॉजिक गेट्स पढ़ा होगा क्लास 12th की बुक से, उसमें 1 मतलब ऑन, 0 मतलब ऑफ, दोनों ऑन तो बल्ब हो गया ऑन, यही बोल रहे हो ना।
यस सर।
ठीक है, हम लोग आएंगे, हम लोग अभी सारे ऑपरेशंस पे आएंगे, क्या ऑपरेशंस होता है वो समझो, बस समझो सिंपली ये एडिशन रूल है। ठीक है, हम लोग आएंगे इसको लॉजिक गेट में कैसे अप्लाई करना है, ट्रूथ टेबल कैसे ड्रॉ करते हैं, सब कुछ पर आएंगे, ट्रूथ टेबल होता क्या है और कैसे यूज करते हैं सब आएंगे, बट ये समझो दिस इज द बेसिक एडिशन रूल। इज इट क्लियर? यस, नो, फास्ट।
यस सर।
ठीक है, तो पहला था हमारा एडिशन, और एग्जांपल देखो, add 101 to 110, ऐड करो। एक और एग्जांपल करेंगे हम लोग, 1 1 0 0 1 1 1 0 1 1 0। अच्छा, अगर कुछ नहीं है तो व्हाट विल राइट, 0 देयर, है ना। Okay, let's see. 1 plus 0 1, 0 plus 1 1, 1 plus 1 1 plus 1 0 with a carry 1, आगे कुछ नहीं है, we will write।
0 with a carry 1।
ठीक है, अब तुम इसको एक काम करो, डेसिमल में कन्वर्ट करके देख लो तो ज्यादा फैमिलिटी आ जाएगा। ये नंबर क्या है जल्दी बताओ। 2 into 0 1 and 2 into 1 2 into 2 4 5 5 है नहीं ये पहला वाला,
5
दूसरा वाला कितना है 6,
6
और दो सम कितना आ रहा है, अरे 11। अरे देखो यार, 2 into 0 से मल्टीप्लाई करो, 2 into 1 से करो, 2 into 2 से करो, 2 into 3 से करो, तो ये 8, ये 0, ये 2 और ये 1, 10 से 11। ये सुनो, क्लियर, मेथड इज राइट, यस। डन, जल्दी बताओ, फास्ट फास्ट फास्ट, डन डन डन। Okay, 1 plus 1, 1. 1 plus 1, 0 with a carry of 1. Now 1 plus 1 is 1, 0 plus 1, it will become 1, 1. The answer will be 1, 1, 0, 1. Right? 1, 1, 0, 1. Clear है? समझो से ये 1 और ये 1, ये 1 और ये 1 क्या दे रहा है? 1, 0. तो 1 तो अगेन फिर कैरी हो रहा है ना इधर. 1 आगे क्या हो रहा है? फिर कैरी हो रहा है. बच क्या रहा है? 0. और 0 प्लस फिर जो कैरी हुआ 1 पिछला वाला, दैट इज 1. क्लियर? क्लियर?
यस सर.
ठीक है, ये करो फटाफट. 1 plus 1, it is 0, carry 1. 1 plus 1, again 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 0, carry 1. Right? 1 plus 1, 1, 0, carry 1. And plus 1, it is 1, it is 1. Done, done. जल्दी बताओ.
यस सर. डन.
सब्सट्रैक्शन सीख ले या कल सीखे? एक बेसिक सब्सट्रैक्शन सिखा देता हूं मैं. ठीक है, बाकी जो है वो कल देखेंगे. कॉम्प्लीमेंट्री मेथड कल देखेंगे. मल्टीप्लिकेशन बहुत बेसिक देखेंगे हम लोग. 5 मिनट में खत्म हो जाएगा मल्टीप्लिकेशन. बेसिकली एडिशन और सब्सट्रैक्शन ही सीखना है हमें. उसके बाद हम लोग पढ़ेंगे बूलियन अलजेब्रा. राइट? सब्सट्रैक्शन के रूल देख लो. पहला रूल, 0 माइनस 0 क्या होना चाहिए? 0. सिंपल है. दूसरा रूल, 1 माइनस 0 क्या होना चाहिए? 1. तीसरा रूल, 1 माइनस 1 क्या होना चाहिए? 0. यहाँ तो कोई दिक्कत नहीं है. फोर्थ वाले में वी हैव टू सी 0 माइनस 1 इट बिकम 0 minus 1 will become 1 with a borrow from the next most significant bit. बस बेसिक यही याद रखना है. So for example 1 1 1 0 0 1 0 1 माइनस करते हैं. Try to understand. 0 minus 1 it will become 1, but 1 we have to borrow here. So what will become? 1 minus 1, 0. 0 minus 1 is what? 1 and 1 we will borrow. So here we have borrowed. So minus 1 plus 1 it becomes 0. Then again 1 minus 1, 0, 1 1 0. Sorry, it is 1 minus 0, it is 1. सही हुआ किसी का?
यस सर.
ठीक है, एक एग्जांपल और कर लूं तो चलते हैं. 1 0 0 0 and 0 0 0 1. डू इट फास्ट। Okay, come here. 0 1 it will become क्या बन जाएगा ये? 0 minus 1 minus is there, minus there. 0 minus 1 1 with a borrowing from next one, right? Again 0 minus 1 it will become 1 borrowing from next one. Again 1 minus 1 become 1. Here we have borrowed 1, so it become 0. एक बार फिर से देखो, 0 है -1 तो क्या बचेगा 1 और एक उसके मोस्ट सिग्निफिकेंट बिट, मतलब किधर जाते हैं हम लोग, लेफ्ट वर्ड जाते हैं, राइट? सो इस वाले से एक ले लेंगे तो क्या बचेगा 1 और ये इससे बोरो करेगा 1, फिर 0 minus 1 अगेन क्या लेंगे 1 और इससे करेगा बोरो 1, इससे 1 बोरो क्या मिलेगा 0। ये सब सबको समझ में आया? इज इट क्लियर एवरीवन?
नहीं सर, ये
I don't understand. 0 here, 0 minus 1 1 with a borrow 1, so here is again 0 and again borrow of 1, so what it will give? Again 1 with a borrow of 1, again here it is 0 and 0, again it will what happen? 1 again a borrow of 1, here it is 1, it will give the 1, remaining is 0. 0 है से 1 घटा, क्या बचेगा 1, और ये 1 किससे लेगा? बगल वाले से अपने, बगल में क्या है 0 0 है, कुछ भी देने को नहीं है, तो फिर क्या रहेगा 1 रहेगा यहाँ पर और 1 बगल वाले से लेगा, फिर क्या बचेगा, फिर 1 फिर इधर से लेगा। क्लियर? अगेन यहाँ देखो 1 minus 1 0, 0 minus 1 it will become 1, but 1 it will borrow, right? And if it borrow 1 from 1 it will become 0, then again 1 minus 0 is 1. वन माइनस 1 0,
सर 0 होगा ना?
हाँ 0 आएगा। Then
यस
here 0 minus 1 1, बताओ फिर क्या आएगा? 0 minus 1 is 1, 1 borrowed, what will be here? क्या बचेगा यहाँ पर? 1 minus 1 1, again here 0, 0 minus 1 1, this will become 0. Clear? सही है ना?
तो जैसे जब कैरी कर रहे थे तो कैरी में तो ऐड हो रहा था, ये बोरो जब कर रहे हैं तो ये क्या हो रहा है जो ऊपर पिंक कलर में है?
तुम समझो कैरी और बोरो करना एक सिंपल सा मतलब समझो, ठीक है? यहाँ पर हमारे पास दो ही चीजें 0 और 1 है यूज करने के लिए, है ना? डेसिमल में बहुत कुछ होता है, तो मान लो अगर तुम्हें 526 में से अगर 49 माइनस करना है तो कैसे करते हो? 7,
हाँ जी।
और बोरो कितना करते हो? 1। अरे ऐसे ही करते हैं ना हम लोग। फिर यहाँ क्या हो गया 1, तो 1 से घटेगा नहीं, तो एक और बोरो करेंगे तो क्या बन जाता है यहाँ पर? 11 में से गया तो 7, 4। ऐसे ही करते हैं ना हम लोग सब्ट्रैक्शन। और अगर हम लोग एडिशन करें 426 प्लस 49 तो क्या करेंगे एडिशन में? 9 6 15, कैरी 1, 4 2 6 और एक 7। ये मतलब है कैरी और बोरो का। कैरी में सामने वाले को देते हैं, देखो मैं लिखवाया होगा एडिशन में, कैरी 1 टू द मोस्ट सिग्निफिकेंट बिट किधर है? लेफ्ट हैंड साइड में, एक देंगे उसको, और बोरो का मतलब उसे एक लेंगे। क्लियर? क्लियर हुआ अभी भी नहीं हुआ?
यस यस।
देखो एक होता है कि नया रूल है तो डाइजेस्ट होने में टाइम लगता है, ठीक है, वो बात हो सकती है, नहीं तो पूरी पूरी फंक्शनैलिटी सेम है डेसिमल सिस्टम की तरह। क्लियर एवरीवन?
यस
चलो, तो हमने जो है बेसिकली आज क्या देखा, फटाफट डिवाइस कर लेते हैं। इलेक्ट्रॉनिक्स देखा, व्हाट इज इलेक्ट्रॉनिक्स? इलेक्ट्रॉनिक्स ब्रांच ऑफ फिजिक्स which basically depends upon the electron flow, right? How we will see this thing. Main focus of our class is the digital electronics, where we have learned about the analog and digital signal, what are the difference between them, how they are alike or different. Next, we have started the number system. We have 4 number system in which decimal and binary, basically binary is the most important, and we need to convert from decimal to binary because decimal we use most frequently. In decimal system and binary system, we have seen what are the differences and what are the common features. In fact, every operation in binary and decimal system are just same, just we need to see the base, how it position matters, and how the subtraction and addition rules are formed there, right? Then we have seen how we can convert binary to decimal and decimal to binary. Then we have seen method like double dad method in binary to decimal conversion and double dabble method in conversion from binary to, sorry, decimal to binary. Then we have seen the shifting of the place point. There is the same effect as we have seen in the decimal point. Again, decimal is the base of 10, so by shifting it from left to right, it changes with the 10 multiple of 10. Again here it is multiple of 2 when it changes. Binary operation, we have seen that everything is the addition. Now next is addition and subtraction rule. Any doubt?
No, sir.
Okay. Okay, bye bye, thank you. Let's end the session.
Okay, thank you, sir.
Tomorrow will be class at the same time. Okay.
सर कितनी क्लासेस लगेंगी ओवरऑल इलेक्ट्रॉनिक्स में?
Electronics 6 7 6 I guess.
ओके